Let's continue at number 9, stating if angles are coterminal. Coterminal means that they have the same ending point. The easy way to do this is to see if you can add or subtract 360 to these angles to see if they end up equaling each other. So if we add 360 to 230, obviously we will not get the other 330, so these are not coterminal. The other way to do this with radians is we can add or subtract 2 pi to them. Here, let's take the 11 pi over 6 and subtract 2 pi to see if we equal negative 1 pi over 6. Making common denominators, that becomes a 6, that becomes a 12, and we do in fact equal negative 1 pi over 6. So yes, they are coterminal to each other. Again, adding, subtract 360, add, subtract 2 pi to see, and you might have to do it more than once to see if you get to the next other angle. Okay, finding a coterminal angle between 0 and 360 to 630. So right now 630 is not between 0 and 360. So we have to keep subtracting 360 until it gets between 0 and 360. 630 minus 360 gives us 270. So we're good. We can stop. It is between 0 and 360. So 270 is a coterminal angle to 630. Doing this for something in radians, 9 pi over 4 is above 2 pi. So we have to subtract 2 pi, making common denominators. Make that a 4. That'll become an 8. So subtracting 9 pi minus 8 pi is 1 pi. Keep the same denominator of 4. So 1 pi over 4, just pi over 4, is coterminal to 9 pi over 4, and it's between 0 and 2 pi. Number 13, we have to find a positive and negative coterminal angle. So we're going to add 360 to 320, and we're also going to minus 360 to 320. Doing each, we get negative 40 for the negative coterminal angle, and then we get 680 for the positive coterminal angle. Let's erase these and scroll down to get to 14. Converting between degrees and radians. I'm going to take the negative 45 and times it, pi over 180, to make it into radians. Doing some simplifying, should end up with negative pi over 4 after we simplify. Then converting from 10 pi over 3, which is radians, into degrees, we multiply by 180 over pi. So the pi's cancel out. Doing some simplifying here, we end up with multiplying straight across. We get 10 times 60, which is 600 degrees, and then just 1 on the bottom, since the pi's canceled out. And that's converting degrees, radians, and radians back to degrees. Let's look at number 16 now. So these questions we're using our given point on the terminal side to find the trig function indicated. Okay, so we're given that the point is 3 comma square root 7 on the terminal side. Whenever you're given a point, we're given it as x comma y, and we want to find the sine. Another way of looking at that point is like looking at a right triangle. Your theta is always on the interior at the origin. Here's my right angle. So if that's my theta, my adjacent is 3. My opposite is the y. So we got adjacent and we got opposite. But we don't know hypotenuse yet. We're going to have to find hypotenuse because sine is opposite over hypotenuse. So we know the opposite, which is the square root of 7. But we don't know the hypotenuse. To find the hypotenuse, h here, we're going to have to do Pythagorean theorem for this right triangle. 3 squared plus square root of 7 squared is going to equal the hypotenuse squared, which in this case, I'll make it c. We get 9 plus 7 equals c squared. 16 equals c squared. And then doing the square root to both sides, we get 4, which is the hypotenuse. That's going to go right here. And that's your final answer. So the sine of that angle is opposite over hypotenuse, which is square root of 7 over 4. Let's do another one. Number 17, cosine is adjacent over hypotenuse. In this right triangle here, here's my theta. My adjacent is -5, or excuse me, the negative square root of 5. My opposite is 2, and we don't know the hypotenuse. We're going to need the hypotenuse for our cosine ratio. Let's figure that out by Pythagorean theorem. So let's do 2 squared plus negative square root of 5 squared is going to equal your hypotenuse squared, 4. And then if you do negative square root of 5 squared, it's going to come out to a positive 5 equals c squared. 9 equals c squared. Square rooting both sides, you get 3 to equal the hypotenuse. So our ratio of adjacent over hypotenuse for cosine is negative square root of 5 adjacent. And hypotenuse we found out to be 3. Rewatch these problems if you are still having trouble. Let's move on to 18. 18, we want to find the tangent. The tangent is defined as the opposite over adjacent. In our triangle here, we have theta at the origin again. -7 is the adjacent. 13 is the is the opposite. We do not need to use Pythagorean theorem because we don't need hypotenuse. In this case, we're just doing tan. So our opposite is 13. Our adjacent is -7. Write down any questions you have. Hopefully you are rewatching if you are still lost.